Hey guys, welcome back. So today, working on these two Generac V-twin engines. These were both pulled from standby generators after showing signs of failure. The one here on the left, we actually pulled out in a recent video due to metal in the oil, and the one on the right was pulled out due to no oil pressure. Now, neither engine is blown, but both are showing signs of problems and obviously need to be fixed. So we're going to open both of these up, try to figure out what went wrong, and with any luck, we'll get these machines repaired. So let me get you set up a little bit better and get going on this. So I think we're going to start with the engine here on the left, the one that's producing metal in the oil. All we really need to do is pull this cover off and get a look, but likely we're going to have to pull the crankshaft, and we can't do that with the flywheel in place. So I'm thinking we should probably start on this side, get the flywheel removed from the crank. Now, we can't actually do that because this cover won't come off with the intake installed. So we're going to have to remove the mixer, the intake manifold, likely we'll pull the exhaust manifold as well, and the bracket down here. So that way the engine will sit a little bit more level. I don't like the sounds of that one. All right, so we're going to get the mixer off next. It looks like the bolts are already loose. So just 2 bolts on each side. And it can be pulled off the intake. Now that could damage the seals, so I might just leave the pipes going into the mixer and we'll instead pull the bolts where the intake manifold connects to the engine. That one's pretty tight. And we should be free, more or less. I think the breather might be plugged in still. And I was trying to avoid actually removing these, but the one on the left pretty much fell out. So likely we are going to need new seals for that. And one thing worthy of note, these are the same engine, but they were installed in different generators. This was an older model Generac generator that this came out of, and this was a newer one. And as a result, there's a few differences, different intake manifold, different breather, and a different mixer, which we don't have for this setup. And the older machine, you can see the breather, different design, the intake, very different design, and the mixer also different. I think next we're going to get this mounting plate removed. Might be easier said than done. These are nylock nuts, so we got to hold the bolt still from the bottom. So now that we have the engine pretty bare, we can get this blower housing off. We have just a few bolts going around. That one right there is not factory, so we're not the first ones in here. And it actually looks like we're missing a few more. If we look over here on this engine, you can see we have 3 on this side, 4 if you count that one. And if you look at this engine, we only have the one up there, and all the others are missing, although they're all present right there. So we're definitely not the first ones in here. Looks like we got 2 more on the back side. That one was loose. And so is that one. Yeah, all these bolts are loose. In fact, the bottom one, I can tell just by looking at it, it's not even screwed in all the way. Yeah, things look pretty clean in here. The coils look basically brand new. No sign of a critter. So definitely a good sign. Anyway, before we pull the flywheel off, I think we should remove these coils. Likely they're just going to get hung up when trying to get the flywheel off the tapered shaft. We also need to pull the cooling fan, so I think we just have to remove these 2 bolts. And once that fan's out of the way, likely we can use those bolt holes for the puller to pull the flywheel off the tapered shaft. So when taking that flywheel nut off, I noticed something which might explain the problem this engine has. Now, all crankshafts, they have some end play, a few thousandths. I'm not sure the exact spec on this engine, but this one seems to be quite excessive. And with the crankshaft moving around like that, that could definitely explain the metal in the oil. And just to show you on the PTO side, that's the end play we're talking about right there. Definitely excessive. Let's compare it to the other engine we have. And this is the other engine, the one with no oil pressure. So that's all the way out, all the way in. Pretty big difference between the two. So let's check the end play on the good engine. And I use that term loosely because this one doesn't build oil pressure, but the end play seems fairly normal. So I just pushed the crank in, and what we're going to do is just measure from the edge of the crank to the edge of the housing right where the oil seal is. And we get a measurement, which I'm not too concerned about what that measurement is, but I'm going to zero the caliper out, and then I'm going to pull the crank out. And we'll take the same measurement, and the reading on the caliper will be the approximate end play. Now, on an engine like this, I haven't looked up the spec, but I would think, between 4 thousandths and, 15 would be pretty normal. And in this case, we're at 19 thousandths. So, yeah, that seems reasonable. Let's check the other engine. And similar check here. We're just going to push the crank all the way in. And we'll put the caliper on the edge of the crank. Extend it until it touches the housing. Like that. We'll zero the gauge out. And then pull it out. And given that amount of movement, I'm thinking it's going to be a pretty high number. I would say 100 thousandths, if not more. And yeah, we're at 108 thousandths. So definitely excessive. Yeah, before we open this up, there's still a few more things we need to do besides pull the flywheel. We need to get the push rods out. The engine's also still full of oil. And a lot of these bolts on the valve cover are loose. Yeah, push rods are not in great shape. Actually, both of them are worn right up here. You can actually feel that. So that was caused by the push rod guide. So if we do end up fixing this engine, I would say we're going to need new push rods. And interesting, we also have a little bit of glitter up here on the top end. So yeah, this engine, it's got issues. And I'm kind of debating whether I want to pull the top end apart or not. You know, knowing what we know about the bottom end, you know, likely the issue's confined down there. You know, I did have this engine running at one point. It sounded good. Did a compression check on it. Each cylinder's at 200 PSI. So other than some possible debris contamination like we just saw, you know, likely the top end isn't in that bad a shape. But I'm thinking, well, let's pull the push rods on the other side. Then I actually want to pull the plugs. We'll take a quick look in there with the borescope and see how things look. That side looks good, no debris. Let's break these adjusters loose. Huh, that one's pretty tight. Wow. It's interesting how the other side was pretty easy to break free, but this one, not so much. Yeah, some pretty appreciable wear right there. The guides themselves look fine. Likely it was just due to the metal circulating in the oil. So that has me a little bit concerned about the crankshaft. Plug that came out looks pretty much brand new. You know, the gap is good. I also pulled the plug from the other side, and same story. You know, plugs look to be in excellent condition. So let's take a look at the cylinder. We're going to start just by looking straight down. And yeah, fairly carbon free. Pretty clean looking. Just rotating the engine a little. I want to make sure we're at the bottom, which we were. So I'm going to back it back up. Yeah, no obvious problems with the cylinder. So let's switch views and we'll use the side camera. And now with the side camera, let's get a look in there. So it doesn't look terrible. I mean, I do see crosshatch. Let me rotate the camera. You can see a valve right there. I believe that is the exhaust valve. And if we go a little further, we should see the intake. Things look pretty good, although I do see some scoring there. But not too bad. You can actually see the crosshatch through the scoring, so likely that is mostly superficial. But yeah, overall, the cylinder on this side looks pretty good. So let's take a look at the other side. And we're going to start with the downward facing camera like we did on the other side. And the piston's definitely not all the way down. So I'm going to rotate the engine a little so we get the piston all the way at the bottom, which is right there. Yeah, nothing terrible. So let's switch views to the side camera. And yeah, similar story over here. There is some, looks like light scoring on the cylinder wall, but there's also plenty of crosshatch. And you can see oil actually on the wall as well. So yeah, that right there, that is kind of the area of thrust. That's the bottom side right here, or maybe the top. Let's see where the light is pointing. So that is actually the top. Let's rotate it 180 degrees and take a look at the bottom. And usually the top and the bottom surfaces have the most amount of scoring, but in this case, yeah, it actually looks pretty good. Anyway, I think you get the idea. It's been about 9 minutes, and we have a long ways to go. Well, the oil is definitely taking its time to come out. So, I've repositioned the engine in such a way that we can at least get the flywheel off while we're waiting for the oil to finish draining. Yeah, I think we're getting pretty close. It's been an hour, and we're still draining. But judging by the amount in the pan, we've got to be just about at the end. So I'm going to crack the engine cover bolts loose, and once the oil is finished, we'll get the cover off. The oil is finally done draining. So let's get this opened up and see how bad it is. It came apart pretty easily, and you can see the metal in the oil. Just a bunch of gray paste down there, which isn't good. But the gears themselves look decent. This is the camshaft up here, obviously the crank, and the two connecting rods. As far as the back side of the cover, things don't look terrible, although we might have issues there. It looks like we have a sharp edge right there and maybe right there. So I don't know if it was wearing that surface. I was kind of half expecting to see a shim, or actually a ball bearing, but in this case we just have a bushing. And that bushing, it's not at the same level as the surface right here. So I don't know if that moved. That might allow for more end play than there should be. But yeah, it doesn't look terrible. That's the oil pump right there, plastic gear, and the pickup screen. So let's keep going. Let's get the camshaft out. We'll get the connecting rod caps off, and the pistons we're going to leave in there, but we'll push them up to the top of their stroke, and then we can get the crankshaft out. So let's find the timing marks before we pull this apart. I see a mark there, and I see a mark down on the bottom here on the crank. So it looks like we're going to have to rotate the engine at least one revolution on the crank before we get those marks aligned. And yeah, that appears to be it. So we have a mark on the crank tooth right there. The other mark on the cam right there. So we should be able to slide this out. The lifters might fall out of place. Yeah, camshaft looks all right. Not perfect. There are some marks on it. So I wouldn't say it's in new condition, but probably could be used again. And the lifters, similar condition. Used. None of that can be felt. So no real concerns with the cam or the lifters. Yeah, that journal's pretty rough. It's hard to believe this engine wasn't knocking. So we definitely have issues, multiple issues with this engine. Anyway, let's keep going. We got one more cap to get out. And the back cap, not great, but definitely better than the one in the front. Definitely not a good thing. So a ton of metal ran through this engine. We saw that with the push rods. Every single one is worn down. So those would have to be replaced, likely the push rod guides replaced, connecting rods replaced. They're not looking too good. And the most concerning thing is actually right back here. You can see this dark area. This got really hot. And this is actually part of the block. So this got hot, it wore down, and now we have excessive end play in the crank. And this whole surface feels uneven. The crankshaft itself didn't fare too bad, but there are some marks on the main journal. None of that can be felt, so that likely would polish out. But the more concerning part is over here. This is what was causing the wear, or at least, this surface contacting the surface right here. And this definitely feels uneven, and there's sharp spots on it. So if we put this crank in a good engine, likely it's going to cause damage, and potentially we would already have too much end play. So yeah, this engine not looking like a great rebuild candidate. So let's turn our attention now to the other machine and see if we can fix that one. I guess, actually, before we move on, let's see if we can sneak these pistons out from the bottom side. This is piston number 2. I think we have enough room. And I can see the skirts definitely took on some wear, although not terrible. So, yeah, pistons actually not bad. All the rings move, somewhere on the skirt, but nothing unusual. Let's check the other one. Rings are free somewhere, but again, not terrible. So I would say the pistons could be reused, just not the connecting rods. All right, so we've got this engine kind of off to the side for now, and front and center is the other one that I'm told doesn't make oil pressure. So before tearing into it, I want to make sure that we have oil and actually test if we have pressure. Now, the easiest thing would just be to get a couple leads on here and test, if this sensor closes when we crank the engine. Of course, this could be the problem as well. So I'm thinking probably the best thing to do is to remove this. We'll hook up just a gauge, crank the engine over, and see if we're building any kind of pressure. Huh. It actually seems like we don't have oil. So, did someone drain it? Or was that the problem all along? Yeah, there's no oil on that dipstick. So, let's add some oil to the engine. And we'll wire this up so that we can crank the engine over. And we'll double check if we have any pressure. Actually, before we waste almost 2 quarts of oil, let's get the plugs out. And I'm going to try to rotate this engine manually and make sure it's not locked up. Yeah, plugs look pretty good. Nice and clean. And nothing's been mechanically regapped, but the engine can't rotate it. So let's pull the screen off the flywheel side. That way I can get a hand on each side of the crank and see if we can spin it then. Okay. Yeah, it rotates fine. I just put my thumb over the left cylinder spark plug hole. And we have compression over there. Let's check the other side. Okay, good. We've got compression on both cylinders. All right, I only put in 1 quart of oil. Now, with the filter change, I think this takes 1.9. But we did not change the filter, so let's see if we have enough to test with. And we do. Actually, we're a little bit over full. So the engine was not out of oil, but it was definitely on the low side. All right, let's see if we can get this sensor off. Yeah, it's pretty tight, so I'm not sure if anyone's had this off to actually test the pressure at the source. There we go. So I believe this is a 1/4-inch NPT fitting. And I'm not going to use any thread sealant on here, so it might leak a little, which is fine. We're just going to do a quick test. And now we just have a quick connect here for the oil gauge. So obviously before we use this, we're going to have to hook up the electric start. So let's do that now. All right, let's just get the zip tie out of the way. And I had to steal some parts from the other engine, so that engine, I'm going to go out on a limb and say that that is a parts engine. Could it be fixed? Yes. But the cost of fixing it, I think, would exceed the value of just buying a new engine. So hopefully this one pans out a little bit better. And for battery negative, it needs to be connected to the block. So I think this might be a decent spot for testing anyway. And the negative terminal, it is actually broken on this cable, so not the best cable to test with, but I think it'll be fine for what we need to do. And I even picked up my very own Lone Wolf 6000. So one lead's going to go to battery positive, and then the other one just goes on the trigger on the solenoid, and when you click the button, the engine should crank. So we get that situated right like that. And I've plugged in the oil sensor or the gauge. So if I click the switch, the engine should crank, but you can see we're not building any oil pressure. Oh, wait a minute. We got 50 PSI at cranking speed, so that's good. So this engine was pulled out of service due to no oil pressure, and we have pressure. So I wonder if the sensor that was on there was the problem. So let's get that plugged back in. We'll test the sensor, see if that's any good. Okay. So the way these work, these are just a switch, and it says NC. That means normally closed. So if I were to test this from end to end, we should get continuity, which means essentially no pressure. Once the system builds pressure, it pushes, it opens up that switch, and that connection should be lost. So we'll get this reinstalled. We do have to reseal it if it's good, but that is to be determined. So we'll do a quick continuity test here. When these leads touch, they beep, and with a normally closed switch with no oil pressure, it should beep, which it does. Question is, will the switch open? So I'm going to rig up a test light so we can visually see when the connection opens, and then we'll crank the engine again. So this is the test light I'm going to use. The other end of this wire, it's connected to battery positive. So if we touch the probe end to any source of ground, it's going to light that light up. So what we're going to do is attach a lead to one of these terminals, and the other lead will just be attached to ground. And since this is a normally closed switch, it should be passing the ground through now to this terminal. So if we put the probe on it, that light lights up. And if the switch is working and we're building pressure, when we crank the engine, that switch should open and that light will turn off. So let's try it. And there we go. So the pressure switch seems to be good. I'm not too sure how to feel about this one. I was told this engine had no oil pressure, but the gauge said we had 50 PSI. The pressure switch also seems to be working. So there's really only one of two possibilities here. Either the engine was pulled out when it shouldn't have been, and we did see the oil was low. So if it was shutting down due to low oil pressure, that could have been a valid alert. The alternative is that maybe this engine has a completely different problem. So I think we should move on and check for compression in each cylinder. We'll check for spark. And if everything looks good, then we should try to start it. Make sure the engine runs well and sounds healthy. So before we move on, actually, let's get a little bit of sealant on here. And make sure you wipe off any of that goes toward the oil. You don't want any of that breaking off and potentially clogging something up. But that looks good right like that. All right, let's see where the compression's at. Generac calls for 185 psi, plus or minus 10%. The last few I've tested have been around 200, so I'm hoping for something in that area. So let's see what we get here. Yeah, plenty of compression. We're at, I'd say 215 on this side. So that is absolutely perfect. Let's check the other side. And on cylinder number 2, we want to see about the same. Yeah, that is a pretty healthy engine. We're very close to 220 psi, so that checks out. Let's check the valves real quick and make sure the clearance is good, and then we'll move on to spark. Don't want to tear that gasket. It looks like most of it's released, but this corner looks like it's stuck to the cover, whereas the rest of it's on the block. There we go. Looks nice and clean inside. So I'm going to rotate the engine manually. Right now the exhaust is open, so if I rotate the engine, the flywheel side, clockwise, exhaust will close, intake will open. So the piston is going down. Now the intake's closed, so the piston should be on its way to the top, which I believe is right there. So Generac calls for 0.03 of an inch on both valves, plus or minus 1/1000th, and the 3 goes in there with absolutely no drag. And same thing with the 4. There is no drag there, so we are out of spec. Let's try something a little bit bigger. How about a 6? Nope. Well, 6 fits on the intake, and a 7 has drag. And the 8 does not fit. So yeah, both valves, they are too big. The intake's, I would say, the worst of the two. So let's loosen up the adjusters, make a quick adjustment, and move on to the other side. All right, that feels pretty good there. And it actually loosened up. So that's pretty typical when you tighten up these lock nuts, that the clearance changes. So in this case, it got loose. Even a 4 fits. So let's use a 0.002 feeler gauge. We'll set it to that, tighten it up, and see where that lands us. let's try a 3. Fits in there with a little bit of drag. How about a 4? And a 4 does not fit. So the exhaust valve is perfect. Let's set the intake. Three has no drag. A little bit of drag on the 4. And the 5 is tight. So we're on the high side of the spec, but we are in spec. And I think originally we were like twice what we should be. So I'm happy with this. I'm going to get the cover back on. We'll check the other side. All right, so we're just past top dead center. We definitely have clearance. We know we have good compression, so we're not at 0. Let's check where we're at. Starting with probably 4,000, so that's the high side of the spec. No drag on the exhaust, and absolutely no drag on the intake. So let's go up a couple sizes. Let's try a 7. And 7 does not fit, so we're not that far off. Let's try a 5. Yeah, no drag really with the 5 on the intake. I think we're at a 6 on the intake. And same for the exhaust. So, yeah, we're not too far off on either of these. All right, let's close them up a bit. They're supposed to be about half that. And just like the other side, we're going to set this to 3 thousandths. Or at least that's what Generac calls for. That is the middle of the spec. So on the intake, we'll try to set it right at 3. And the exhaust ideally would be on the high side, like closer to 4. And I can feel that loosening up as I tighten the lock nut. So let's instead set it at 2. All right, let's see where that got us. 3 fits in there with pretty much no drag. 4 has drag. And a 5 is pretty tight. So, yeah, we're on the high side of the spec, which honestly I think is fine. So make sure that's snug. And then we'll do the same adjustment on the exhaust. So let's just make sure we're where we thought we were. 4 thousandths fits pretty loose, which is the high side of the spec. And a 5 actually has a fair amount of drag. So we're set to 5 thousandths, which technically is a bit over. But for the exhaust, I think that'll be perfect. So let's get the cover back on. So we're at the point where we can get this thing fired up. I want to make sure that we can maintain pressure once the engine warms up and that the engine runs and sounds healthy. But as mentioned earlier, this engine, it was for a newer standby, the Evo series. And as a result, we actually have a different intake, different breather, and a slightly different ignition system. So those parts need to be swapped out with the older style Nexus intake and mixer. So that we'll do in a minute, not a big deal, but I am still concerned with how easy it was to fix this engine. We found that the oil was low, we added about a quart of oil, and now we have oil pressure. And I kind of wish I had tested it before adding oil because, my estimate based on where we are now on the dipstick is that we were down maybe about half of where we should have been. And you can see from the stain on this oil pump where the normal oil level is. And I'm thinking we were somewhere around here, which is still above the level of the pickup. So the other possibility is that the pickup might be damaged. And because we're overfilled, we're actually over kind of the level where the pickup goes into the pump. So what I want to do is one last double check is to drain the oil down in this engine so that it's kind of at the bottom of the dipstick and rotate the engine again and see if we continue to build pressure. So we've got the engine draining down and it's going to take a while. So while waiting for that, let's start the process of converting this engine over. And this here is the main thing that we're after under here. So I believe we can just swap the tube and not pull the cover. Worst case, we can just pull the cover with the tube and swap it out for the older style on this engine. All right, I pulled the breather from the other machine in the same way. So we just need to get this into that, which this wire is kind of in the way. So I'm going to unplug it for now. And set it aside. There we go. So we get this kill wire reconnected. Originally I was thinking about changing the coils over. The Nexus style coils, they are a little different. Not the coils themselves, but actually this wire, where it connects to the control panel. This one uses a bullet connector, whereas the other uses a ring terminal. And, I don't even know what kind of machine this is going to go on. So we'll convert this if needed when we install this on a generator. So I'm going to use the blower housing from the other machine. The one we pulled off of here had a little bit of corrosion right up here, and this one's in better shape. All right, so the oil, I've dropped it down, not quite as low as it was when we got the engine, but pretty low. It's right at the tip of the dipstick, just below the safe mark. But with this much oil, I would still expect it to build oil pressure, if that pickup screen and tube are good. So I've reconnected the pressure gauge. Let's crank the engine and make sure we're still building pressure. Yeah, same as before, 50 PSI. So I think that's good. I'm going to bring the oil back up to where it should be, and then we can finish it up by getting the intake and the mixer on. Yeah, we're just there. Maybe a touch over full. Pretty much perfect. Before we get the plugs back in, let's just check and make sure we have spark. So I'm going to kill the overhead lights and zoom you in a bit. Let's turn the engine over. Yeah, and we have strong spark. So let's just make sure we can kill spark now by grounding out the ignition coil. So one lead on the kill wire, the other end of the lead can go to any source of ground. And we'll turn the engine over again, and we should not have spark. Okay, beautiful. So let's get this plug installed, then we'll go to the other side and check the same. And let's do the same test over here. The only difference is we now have one plug in, so the engine's going to be bouncing around a little bit since we have compression on the other side. The kill wire, it's removed, so we should see spark at the tip. Let's try it. And yeah, we have strong spark. And if we ground out the coil, that spark should go away. Perfect. So next, let's get the exhaust manifold on. So I'm just going to secure the right side loosely, and then we'll work on the left. We need to fish the gasket in there, secure it down, and then we can do the same for the other side. All right, so I think it's best to get the mixer on first and then the intake pipe. So there's a couple things I just want to take note of before we install this. And I guess first off, the throttle position. So if we pull this forward, throttle plate closes, back is open. And we also have like an idle set screw right here. So we're going to need that for testing because we're not going to have a servo controlling this. So we're going to have to hold this against the idle set screw and then just dial in the speed as needed. You know, as far as the seals go, they actually look to be in pretty good shape. So we might be able to reuse those. Same thing on the other side. So let's get this bolted down and get the intake attached. So as far as the intake tubes and the seals go, they're actually in pretty good shape. It's a nice fit. Now, one thing the factory does is they do apply some silicone, actually on this surface right here, I believe. And when they assemble it, you know, it just pushes the excess out. So I'm not a big fan of it, but you know, apparently the factory thinks it necessary. So I'm going to clean up this old stuff and we'll apply some new and get these tubes reinstalled. All right, now we need to get the engine onto the standby generator frame. Now we are going to use the correct engine mount, but it is meant to work together with the stator mount. And without the stator, the flywheel actually overhangs the mount and the whole engine's going to want to fall forward. So I reinforced this mount a bit. I added an extra foot on each side, and I'm hoping that will be enough to keep the engine where it needs to be. And we're going to get the fuel lines connected next. You know, this regulator, it is metered for propane or natural gas. You have two feeds going up to the mixer. And there's actually a valve on the mixer to essentially choose which source you want to pull from. So we'll double check it, but we want to make sure it's metered for propane. And as far as the throttle goes, we need to hold that in the forward position, but we don't want to fix it rigid because we are going to have to fine tune it with that idle set screw. So I am going to use a bungee to hold on to it. And I think we can probably clip it down here like that. So now we have pressure holding it in the idle position. And this is the valve here I wanted to check. There is labeling right here. It's probably hard to see, but it is labeled natural gas in the in position and propane in the outer position. So we want to leave it there. The other thing we need to deal with actually is the auto choke. We're not going to have that functional during that test, and the default is to choke the engine. So we cannot leave it like that. So we either need to find a way to hold this open or potentially just remove it altogether. And I think the safest thing would be just to remove it altogether. You know, otherwise we're going to have to find something to secure this. And I'm just kind of worried that whatever I use could come loose and get sucked down into the intake. And without the auto choke, likely the engine's not going to start without a little bit of help. Oh, we're getting pretty close. You know, at this point, all we have to do is hook up fuel and try to start it. That said, though, it's going to be pretty loud without the exhaust. And my wife actually works right above the garage, so I want to keep the noise down if I can. The issue is the exhaust kind of mounts right here in midair. You need a divider and potentially one of the side panels to help secure it in. So let's try to fit that before going for the first start. That actually seems pretty secure, so I don't think we need to add any of the side panels. You know, this should be good enough at least for a few tests. And I did also add a strap because I'm a little bit worried about this thing jumping off the table once the engine starts. You know, I have connected a lead to the kill wire so we can shut things down pretty quickly. We also have a couple leads running to the fuel valve. So if we need to shut it down quickly, we can pull these leads, shut the propane off, or ground out the coils. And we've got the starter trigger connected, and we should theoretically be ready to go. Now, even when I power the fuel valve, you know, it's only going to let propane advance to the regulator. This will not open up until there's enough engine vacuum, and without the choke, likely it's not going to open on its own. So I did pull the cover back off, and if needed, we'll just choke this manually, which should allow the propane to flow and the engine to start, assuming the throttle plate is open enough to allow that. I'm pretty sure we're going to have to tweak that, but we are as ready as we're going to be. So let's crank the engine and see if this thing comes to life. All right, so the propane's on, fuel solenoid is active, and I bled the line, so we should have propane pretty much right up to here. So I'm going to crank the engine. I might have to choke it manually. Probably have to work the throttle as well. So, contact. Yeah, it's trying. Yeah, it's trying. I'm not sure the throttle's opening enough. Let's try it a few more times. Okay. Engine sounds good. Give a little throttle. So it's not getting up to speed, even with full throttle. It seems to need choke, but let's try it a few more times. I'm wondering if that choke that I took off, looks like it might be a through hole. So that, if that's the case, then yeah, I think that's going to cause a vacuum leak. So we need to plug that before we try this again. All right, I just put that choke back in without the spring, so that should plug the leak. So let's re-energize the fuel valve and try this again. Well, I was kind of worried about getting the engine started, and I wasn't even paying attention to the gauge, and I just looked over and the gauge was pretty low. So let me situate this where you can see it. We'll try to start it one more time, but I would say we actually do have a pressure problem. All right, so the propane's currently off. I'm just going to crank the engine. And you can see the oil pressure not as good as it was when we were testing it earlier. So yeah, that is not a good sign. But at least the engine sounds good from what we've heard. I do want to run it for a second. I ended up pulling the auto choke back out. It was just kind of getting in the way. So I've got that capped off so we don't have a vacuum leak. I do want to start it at least for a second, but I think we're going to have to shut it down pretty quick given the oil pressure reading. So let me turn the propane back on. And we'll try to start it. I was a little concerned that this one was a little too easy. I was told it had no oil pressure, and the testing we did earlier said otherwise. We had plenty of oil pressure, and during the course of cranking and trying to get this engine to start, something happened. That pressure is virtually zero. And although the engine sounds good, it's not going to continue to sound that way if we keep running it with the pressure like it is. So unfortunately, we do have to open the engine up. So, likely I'm going to leave it right where it is. I'm just going to pull the exhaust off, drain the oil, and we'll get the cover off and have a look at that pump. All right, so we've got the exhaust out of the way. The oil is draining out. It is just about done. So I'm going to crack these bolts loose, and once the oil's done draining, we'll open it up. And I'm hoping it's going to be something obvious, because there's really only one of two possibilities: a bad oil pump or a bad engine. And the engine sounded pretty good, so I'm hoping it's the pump. The engine looks pretty good. I don't see any problem. There is no, what is that? I was going to say there's no metal in the oil. And that's not metal. I'm not sure what that is. It almost looks like the same color as the pump gear. Interesting. You can kind of see it right there. So, yeah, I wonder if something is contaminated. I'm not sure what that is. The gear itself looks fine. I don't see any missing teeth. The pickup is intact. Pickup screen looks good. But yeah, this junk on the bottom, I'm not sure what that is. So I don't know if we can open this pump up, but I'm kind of curious to see if we can. The bearings appear to be in good shape. One of the test procedures that Generac has is to run the engine for about 20 minutes to see if the pressure drops. So that was the plan. Because the pressure drops after the engine warms up, then that's because the oil is thinned out and likely you do have bad bearings. But in this case, the engine barely ran at all. That oil was still cool. So I've got to imagine that the problem must be inside the pump. The pump looks pretty good. You know, I was really hoping there was going to be a smoking gun here. You know, it's a fairly common failure for the teeth to just get chopped off that gear. And then, of course, without the teeth, it won't spin the pump. But the pump looks good. I don't see an excessive wear. Pickup screen and the seals on the pipe. You know, everything looks good. You know, this pump also has to seal on the housing right here. And although there is a little discoloration, you know, it's nothing that can be felt. So I don't think this is the failure. You know, that looks good and the pump looks good. So what I'm going to do is actually reattach this. And we're going to dunk it in the oil that we just drained and just spin the pump. See if we can get it to work and potentially replicate the pressure problem. All right, so we got the pump here sitting in the bucket of oil. And if we rotate the pump, you can see it is pumping oil like it should. So I'm going to try to cap that off. I'll spin it, and I can feel the pressure. Although, yeah, something's not right. So if I spin it slowly, I can feel it building pressure against my thumb. And if I spin it fast, right there, it just freewheeled and there was no pressure. Right there, did it again and again. So when it freewheels, I don't feel any pressure and there's no resistance. It almost seems like maybe the wheel is spinning, but not the pump. So let's get this back up on the lift. We'll get this pump removed. And what I want to do is hold the pump still on the other side and see if maybe this plastic wheel is spinning separately from the pump, which it shouldn't be. But if it is, then that would explain the problem. So I've seen this issue before, but not with this type of engine. It was actually a Briggs Quantum where the timing was completely off, yet the timing mark wasn't off. The issue was a plastic gear on the camshaft, and the camshaft was metal, so those two pieces kind of moved independently. The valve timing went off and that engine stopped running. And we have something similar here. We have a plastic gear joined to a metal shaft, and on the surface seems to work fine. But if I hold this still, I should not be able to move this gear. But you can see I can rotate that gear and the pump doesn't move. So yeah, this is the issue. So the good news is we know for sure the point of failure. So all we need is a new one of these and we should be back in business. And I know some of you are probably yelling, don't buy a pump. You have a good one here on the parts engine. And although it might be better than the one we just pulled off the machine, you know, this pump has hundreds of hours on it, also has a plastic gear and has been running metal through it. So likely it is not a good choice, and a new pump is only $55. So we've got a few days until the new pump shows up. The new pump, it is going to come with a new tube, new seals for the tube. But surprisingly, we do have to reuse this pickup screen. So I'm going to get that safely out of the way. And then I'm going to drill these rivets out that hold this cover on. I want to get a look at that gear, see how it's supposed to be attached and what exactly failed leading to this problem. Not a lot to see here, at least on the front side. Just going to rotate it, hold it still, find a loose spot. Actually, that's a loose spot right there. And I'm just trying to pull the gear off the shaft, and it's actually holding on there pretty tight. Let me pry it a little bit. Yeah, it's not budging off of that shaft. So how can it be stuck on there so good and not even turn the pump? It's actually worse now. Completely freewheeling without applying any pressure. So yeah, kind of thought it would just fall off. So I'm going to keep working at it. We'll get it off. It just launched 4 feet in the air. I'm kind of surprised at how much effort it took to get this gear off. Given that it was freewheeling on the pump, I half expected it to just lift right off. But that was not the case. I spent about a half hour heating and prying and finally got the two apart. But now that they are, at least we can see how they were attached. This gear likely was molded around this piece. And the shaft, 100%, did not fail. I cannot hold the pump still. The shaft does not freewheel. The failure was the bond between the plastic and this piece of metal. And there's not a whole lot left to do other than wait for that pump and clean up some of this stuff right here. So I think this is sludge mixed with water. So, you see that usually when oil and water mix, the engine runs and the oil turns white. But this is kind of the first time I've seen it just on the sludge. The oil that we drained out actually looked pretty clean. All right, so it's a few days later, and I think we have what we need to get this engine fixed. It is a new oil pump. We also have a new tube and new seals. Now, oddly enough, the seal for the pickup tube did not come with the new oil pump, so I did order that separately. So I'm going to get the old seal off, we'll get the new one in its place, and we'll get the pickup screen installed, and then we'll install the pump. Okay, new pump seems to rotate fine. The gear cannot move separate from the shaft, so that is a good thing. We do need to get the pickup tube installed, which goes in right here on the side. So just get a little bit of oil in there so we don't chew up that new O-ring. And we're going to insert the pickup kind of like that, being sure not to drop anything, and we already dropped something, so we'll get that fixed. Alright, so that is installed. We need to align these holes, and now the hole for the pickup is also aligned. So the original bolt did not have any thread locker on there, and I am going to add just a little bit. There is a torque spec on this. I think it's like 7 inch-pounds, which I don't have a torque wrench that goes down that low. So we're just going to make it snug with some thread locker for insurance. All right, so we got the pickup reinstalled. Not a big fan of this tiny little bolt going into plastic. That, seems like a potential point of failure. But let's get the pump back together. The gear had the two dots facing up, and I believe it was clocked right about there. Not that it should matter too much. There we go. All right, so we get the tube installed next. The O-ring's been oiled up, and the tube's not the same, meaning this side it is longer. So that is the side you want going down towards the pump, and the shorter side goes up here into the cover. And the last thing we need to do is replace this seal right here. This basically connects the oil pump to the rest of the engine. And although I'm sure this seal is good, it seems silly not to replace it, especially when we're dealing with oil pressure issues. So we'll get that one out and get the new one installed. Generac calls for 35 foot-pounds on this, so I'm going to bring it up to about 20 and then finish it up at 35. Yeah, it's hard to see. It's so clean, but we are full. Actually, just a tiny bit past full, which is going to be perfect because the oil system, it's not primed. So that level is going to drop a bit once we crank the engine. So I'm going to take a second, just reconnect the battery. We'll crank the engine over and just double check that we now have pressure. All right, let's see what we have for pressure. Oh, there we go. All right, so similar to before, we now have 50 PSI. The big difference is that gear isn't going to slip, so we should be able to maintain it once we get the engine started. Beautiful. So we're all back together, got the exhaust added back in, so place your bets. Is the engine going to run? And are we going to build pressure? I think the answer is yes to both, although we are going to need to fine-tune the speed just a bit. So let's crank the engine and see how it performs. All right, let's get the engine started. So the propane tank is on, fuel solenoid is energized. The pressure gauge is right there, so I'm just going to crank the engine, not really trying to start it, just to build a bit of pressure. And now let's try to start it. Going to bring that idle speed up just a bit. All right, let's try it there. Okay, we almost had it, but it is definitely too slow still. So let's bring that set screw in a little bit. And let's see what that gets us. Yep, not enough. All right, that sounded pretty good. But the idle set screw not holding the throttle open enough. And we're pretty much maxed out as far as how far that can go in. So, you know, that's probably not for setting the idle speed. You know, normally this would have a servo on it. So we might need to control it by hand. So let's try to start it again. Nice. So I'm going to get this cover back on. The engine is running a little bit rough, and I'm not sure, you know, if we have other issues potentially going on. So, you know, running without the airbox definitely is not helping. The thing that complicates it is this bungee and the fact that we have a choke that is being held open. But I think now that the engine's warm, you know, likely we can get it started without using the choke. All right, let's see if we can get it started. All right, and that was a pretty good test. Going into this, I wasn't sure we were going to be able to get this engine running. Usually there is a very massive rotor attached to the crankshaft, and I wasn't sure if the flywheel had enough mass to run this engine stably. But thankfully, we were able to get it started, and we were able to dial the speed into about 3,500 RPM. And at that speed, we were producing plenty of oil pressure at 60 PSI. So, luckily the controller in the machine that this was originally installed in shut the engine down very quickly once that old pump blew out. And for only $55, we were able to throw a new pump in it and get this machine running like it should. So I would say this is ready to go and will definitely be used in a future project. So I hope this video helps someone. Thanks for watching. All right, I can't resist. Want to hear it run just one more time.